All right, this last video is just going to kind of sum up a misconception that a lot of students have, and that's that strong can really, really hurt you and weak can really, really hurt you. And in chemistry, strong and weak, when it's referencing acids and bases, are very, very different than a conventional thought on the matter. So a lot of people associate concentrated and dilute as being the same as strong and weak, and that is a very, very big misconception. Strong and weak, in terms of how we're talking about acids and bases, deals with how completely they break apart into water. That's going to be called how much they ionize, or how much they dissociate. A strong acid or base will completely 100% ionize when placed into water, meaning that you will not have any more HCl's in this case, you'll have only H plus and Cl minus. Weak acids and bases are a range, anywhere from 1 to 99% dissociation. Weak, however, does not mean the ability to not cause any damage. So if you look at this picture off to the right, you see that we have acetic acid. Acetic acid is considered a weak acid because it does not completely break apart. What that means is that you're going to have some of these pieces that still are stuck around. While some of them break apart into their ions, and therefore will cause the damage. It's partial ionization. Now we could get into a lot more depth about this in terms of the calculations associated with it, but the basic idea holds true. A weak acid or base does not have anything to do with concentration. It has everything to do with how it breaks apart in water into its constituent parts. The last thing I want to touch on is this concept behind titration. Titration will be bringing about the process of neutralization. We talked about neutralization earlier in this year when we talked about the different reaction types. And neutralization is a specialized version of a double replacement reaction. So a couple things that we have for a neutralization or a titration procedure. You're always going to start out with an indicator in your solution. An indicator actually shows the presence of different pH ranges. Some common indicators are down here. Titration occurs by adding a small amount of an acid to a base or vice versa. As that small amount has been added in, a color change will occur. When that color change becomes permanent, the end point has been reached, and that is when you have equalized or balanced out or neutralized the reaction.